Yo, what up? Is this thing on? Can you guys hear me? Hello, hello. Cool. All right, looks like it's working. So, welcome. Welcome back if you're returning. Welcome if you're new. I think last time I was messing around with this, I was digging through the GG read sector memory function, playing around with that and trying to figure out how the hell it works. Let's see, let me get my windows open because that usually takes a little bit. I know I should have had this going already. It's having some issues with my system lately. I think I figured out why it was crashing. Um, Kind of a stupid problem, but it was overheating. My GPU that I passed through to my Linux system, for whatever reason, the fan control uh wasn't working through the firmware like it's supposed to. So I had to install some software to make it actually work properly. So that's cool. Alright. And get this attached to the VM. Add our USB device. And let's make sure it turns on. Or is it going to be like this again? Yeah, I fear that it is going to be annoying once again. Last time I attached it to the Windows VM and that made it work right. So let's try that again. Yeah, there we go. Now it turns on. I guess there's something with Linux where it doesn't um send like an initialize command or something to the USB device to like just check its descriptors or something, and that causes it to not turn on. I don't know, honestly. I wonder if I can emulate that. Who knows? Whatever. Remove it. And then we will pass that back into Linux. I'll have to figure that out though. It may just be because it's a VM. Who knows? Alright, CD to our desktop. And we're going to source virtual environment. Okie dokie. And what was the last thing that we were doing? The display pad worker was going through is setting the main brightness. We already did that. And I think we wanted to test, we were testing the output of this function, the GG read sector memory. Gotcha. Okay. So running is true. I think I took out that read sector memory call. I just run it, make sure everything's working before I start messing with stuff. Can't handle the OBS. Oh, I do this every single time. I need to change that as well. Alright, cool. So it looks like the device is working. I can send inputs. All that is good. Okay, cool. Alright, I just wanted to make sure it's still working. Even though I haven't done anything to it. Was it read sector memory? GG read sector memory. And then what do we got in here? We got the sector index, address, length, interval. Alright, I'll stick those in there. And then that should print out the message. I should print out the message when we go run this next. Required argument is not an integer. Okay, cool. Which one though? Which one is not an integer? Oh, it's probably length. Is it the header? Oh, it is the header. For these other ones, where's my header? Read sector memory. I gotta get the 0th item. Those were actually integers. Where are we at? So this is our read sector memory, and I am going to make our header the first item in that array. Because I'm guessing that it's pulling that array and trying to pack it. Okay, so 19.0.0.0.1. Okay, so let's go ahead and check our windows. Should be up. Alright, cool. Alright, so I'm just going to open that, but really I want to look at wireshark because I want to confirm the messages. Oh shit, I didn't run it as admin. I should really add more cores to the system. Do 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 do. I don't know, what is it, the disk? Oh, it's the disk. Removable. That's like mad slow. There's probably a way to speed that up, but who cares? I don't think this is right. I think it should be. Okay. Nom 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 nom. Yeah, sure. Recover my unsaved changes. Do 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 do. Oh my god. Y'all wake me up. Waking me up when it's done loading. Okay. So this is done. We were under. Oh, I guess it's not done. It's still thinking about it. Okay. Exports. Dude, holy crap. Oh. Yep. Yes, we'll save it. I'm gonna close that out. Close that out. Get out of here, wireshark. Alright, I'm going to do this. Gonna make it run a little bit faster. Alright, whatever. I should have some protocol notes in here, I think. No, that's on my other disk. Okay. Wow, that's gonna take a while. I didn't realize the USB storage in QEMU was so slow. Okay. Well, while we wait for that, because I need to look at the actual message that gets sent to confirm that I'm packing the data properly. So let me work on the docs really quick, because that's what I'm supposed to be doing, at least according to my stream info. So where was I last time? Let's go ahead and I'm gonna look at this real quick. Markdown, preview in browser. Yeah, let's clean this up. So our action types, keybind, switch, OBS CMD. Markdown is pretty annoying in my opinion. Just trying to get everything like aligned properly. Do, 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 do. So panel JSON settings, panel config consists of basic options and a key mapping dictionary that corresponds to each key. We have a name, background, color, order. Each key has a dictionary item within the key mapping dict that consists of an action value and icon value. Action, value, and icon. Action types. Should probably rename this to like action type or something. I don't know. Or just rename this to actions. Okay, where's my markdown guide? Markdown syntax. Let's see. Lists. Code. Emphasis or block quotes. Do I want block quotes? Block quotes? I don't think I want block quotes. Actually, block quotes might be good. Let's see what this looks like. Yeah, the block quote's not gonna get the new lines in this, I don't think. Or do I need to double space them? Yeah, it's not gonna. Okie dokie. Keybind. Let's see, modifier keys. We can make this I don't know if that'll be a sub element. I mean, I could have like the modifier keys and everything in a I think I'll do that. Let's see. I'm gonna take these modifier keys out and move the description of those into a different section. Action or keybind. Alright, I do like the way that looks better though. Have the block quote. Oops. Yeah, it looks alright. It looks better than it did. Actions, keybind, switch, OBS, CMD, and then we can like detail that elsewhere. Let's see how Windows is doing. You done copying? Okay. Alright. Let's go back into Windows, see what that's all about. What are we doing over here? Okay. Cool. Oh, jeez. What's the point in a portable app if you can't just fucking move it around your disk? What? Am I the only one that's confused about that? Oh man, that's so much faster. Wow! Look how much faster it is. Holy crap. Okay. Read sector memory. I'm going to here. Sector address, length, p data. Yeah, And then the message that it actually sends to the device is going to be this right here, local 50. Okay, so I need to figure out what the hell this actually means. 0122. I'm not sure what this notation is about. I think I mentioned this last time on stream. Let's look at our key presses pcap. Now I want to look at, is it data? No. There we go, leftover capture data. Okay, so this is what's getting sent by the native software. This message right here. Let's go ahead and copy. Ooh. Copy the value. Make sure I got the right value. Alright, cool. And I'm just going to open up a text file, make some notes real quick. Okay, so this is what we should be sending to the device. This is what we are sending. So it's a wee bit different. Alright, so this is kind of the tricky part, is I need to determine what all of the fields are in this data. It's actually getting sent to the device, so in ghidra, this is our header. Alright, so let's see, we set up our ESP. What is this adding? Okay, that sticks our, terminator, I guess. And shift right, binary, I guess? Or, sorry, bytes? I'm not sure what the, what is that? What is that designation for? No idea. Whatever. So, looks like we're building our message in the stack pointer over here. We're adding or concatenating that, and then this value, which I'm not sure. I guess that's 0. I don't think ghidra pulled that out of the thing properly, or decompiled it properly. Let's see. Let's look at IL spy. We can look at the default parameters that get sent. So that may be the where is it? Get sector, read sector memory. There it is. So there are a couple default values. Let's see where this actually gets used. We'll analyze it, go to used by, and go over here. Here we go, display pad, read sector memory. And then we do displayed pad SDK read sector memory, and we call it with the iSector index, which is 0, iSector address, which is 0, number 4096. So we need to do, is number our length? Yeah, 4096, right? And then our interval is still 2. Number, integer pointer, and then interval is 2. What is this text for? Where does that get used? Oh, okay, that's the variable that's going to hold the GUID when it comes back from the device memory. Okay. And then let's see what that results in. Curious. Go back into Linux. I want to save that. Gonna run it again. See what that spits out. Maybe it's similar to the actual. Nope. Oh, here we go. I need to come over here. Let's just not actually pass this any parameters. We'll call it the default parameters. That'll make it easier to manipulate over here as we're working on it. And I'll go ahead and rerun that. And it's the same result. Okay. Length is 4096. Let's do that. Add another integer in there. And then what is the sector index bytes? So we start off with the header, and then we add that 0 for whatever reason. And then we've got the I length shifted to the right by 8. And then we have the interval. And we push that to our stack. Okay. Let's check our length value. Let's make sure that we're shifting that by 8. Let's do that. I'll shift that value over by 8. I still don't see our interval. So length, sector, okay, I am getting lost. Lost in the sauce. So we got our sector address. Let's write this down. Sector address. And then what was that? 0 for whatever reason. And then we have I length shifted by 8. And then we have I interval. What is this thing? The PIR. Okay, so that's after the fact. Okay. Go back into Linux. Come back over here to our notes, paste that again. So we have our sector address. Oops. Sector address 0, I length shifted by 8, and then the interval. Oh, I guess this is supposed to be the start value. but it defaults to 0, so I guess no matter what, you can't really pass it anything and expect it to give you something else. At least through the native software. I don't know. We'll experiment with that. So that's the length. Then we have interval. One, two, three, four. Let's take one of those out. Do this. Spit it out. Watch it complain. Or be wrong. So let's take this value, come over here, and paste it. So our interval, do we need to... We may need to, pack these values differently. Not sure what that's actually expecting. Is that what this means? Is that what this notation is? Is that these are packed together? 0, 1, 1, 1. So the sector address is packed with that? AL, DL. AL and DL values. Sector. Oh, see, interesting. Wait, that's the interval. AL is supposed to be the sector address, but it says that it's the length shifted to the right by 8. Is that just because... Oh, yeah, because it's overwriting that again right here. So this isn't actually the I length. It's actually sector address. So I think that's what's throwing me off. Byte pointer, sector address. So it takes the byte pointer for local 4F, which is... No idea. G49, 4A, 4B, C, missing D. Huh. Alright. Let's get our x86 assembly reference. No, wait, this isn't x86, is it? It is, No, I'm sorry, it is. Because this is the DLL file. Do, 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 do. Oh, nice. Alright, so that's an accumulator. You don't have to use it as an accumulator, typically, but So it's dealing with 8 low bits on this value. I'm not sure what that actually does, if it truncates the, I'm pretty sure it does. It's gonna truncate that value. Basically pull the 8 lowest bits from the sector address, right? x86, move, AL. um, I don't think it's doing anything funky with that. It's an 8-bit register, and it's taking the sector address, stuffing it in there. And then what does it do with the